You might have noticed, looking at the special right triangle, say a 30, 60, 90 triangle, that the sine of 30 degrees, which is a half, is the same as the cosine of 60 degrees, which it is. And you might also have noticed that the reverse is also true, that the cosine of 30 degrees, also known as pi over 6, which is root 3 over 2, is the same as the sine of 60 degrees, pi over 3. And you may wonder, is that a coincidence? Is that just a one-off? Or is this something that happens dependably sometimes? And if so, when? It's the second thing. It's not just a coincidence. You might notice that 30 degrees and 60 degrees, pi over 6 and pi over 3, add up to 90 degrees, or pi over 2, which is the same thing, which makes those two angles complementary. They're complements. Two angles are complements if their total, when you add them together, is 90 degrees or pi over 2. In fact, the co in front of cosine stands for complement. So it's not at all a coincidence that this happens. In general, the sine of an angle is the same as the cosine, its cofunction, of its complement. Well, its complement is the difference between the angle and 90 degrees, since 90 is the total. So in general, no matter what theta is, well, we're talking acute angles here that you could put in a right triangle, the sine of an angle is the same as the cosine of its complement. This holds true for all the cofunction pairs. The cotangent of an angle is the same as the tangent of its complement, the difference between the angle and 90 degrees, or pi over 2. I put 90 for one and pi over 2 for the other. Doesn't matter, they're the same, just a matter of what units you're in. And the secant and the cosecant work the same way. The secant of an angle is the same as the cosecant of its complement. And I could write all three of these reversed too. The cosine of theta is the same as the sine of 90 degrees minus theta, and so on. What does that do for us? Well, sometimes it can make our lives a little bit easier, a little bit less complicated. Suppose I want to know, I have the sine of 72 degrees, but for whatever reason, I want to express it as a cosine of something. Well, I know that sine and cosine are cofunctions, so the sine of 72 degrees is the same as the cosine of its complement. Its complement is the difference between that angle and 90 degrees specifically, which is 18. So the sine of 72 degrees is the same as the cosine of 18 degrees. If I know, or if I have the cosecant of, let's say, 36 degrees, but I want to express it as a secant, well, cosecant and secant are cofunctions, so the cosecant of 36 degrees is the same as the secant of its complement, the difference between 90 degrees and 36, which I believe is 54. So the cosecant of 36 degrees is the same as secant of 54 degrees. Might as well go for broke and do a tangent one. The tangent of, let's say, pi over 8, and I want to express that as a cotangent. The secant of an angle is the same as, the tangent of an angle is the same as the cotangent of its complement. We're in radians now, so I'm going to use pi over 2, the difference between pi over 2 and pi over 8. Little common denominator action here, so that we can actually subtract them easily. 4 pi minus 1 pi is 3 pi with my common denominator. So the tangent of pi over 8 is the same as the cotangent of 3 pi over 8.